What's up, everybody? Mr. Murray here, back on Mr. Murray's Mathland, and today we are doing a little review of complex numbers. I would say in general this is designed to be for, say, pre-calc, where you've learned about complex numbers in Algebra 2, and now we're starting to use them again, and we're getting a brief review of a few of the types of operations you can do with them. But yeah, if you haven't learned about them, don't let it stop you from watching. So for example, suppose you were trying to solve this equation. 3x squared plus 70 equals 10. Hopefully your algebra instincts would kick in on this and say, let's isolate the quadratic term, the x squared part. And so I'm going to subtract 70 from each side, and I'll have 3x squared equals negative 60. Then I'm going to divide by 3. And then I'll have x squared equals negative 20. And now to solve for x, we take the square root of both sides. So a couple algebra things here. When you take the square root of both sides, remember that you need to consider both positive and negative, plus and minus the square root of that opposite side, right? Because x squared always has two solutions. For example, if you were solving x squared equals 25, x could be 5 or negative 5, because if you square either of them, you'll get positive 25. So always, an easy thing to forget is that when you take the square root to isolate, remember to consider plus and minus. But now here's what today's video is about, is taking the square root of a negative number. And that's where we get into this concept of imaginary numbers. Imaginary numbers or complex numbers, as we'll clarify in a moment. But the square root of negative 1, that's kind of our building block for this whole concept. That, the square root of a negative number, we call that I for imaginary. Because what real number, if you square it, could you get negative 1, right? The square root of a negative number isn't something you can wrap your head around. What times itself gives you negative 1, right? So that's definitely the big idea to remember here. So if you're a little rusty with simplifying square roots of negative numbers, the idea is that you can always pull the negative out, the negative 1. You can factor that out, and that portion becomes I, right? Square root of negative 1, and then root 20, reducing that should be pretty easy for a student of this caliber, but that would break down to root 4 times root 5, and 4 being the perfect square, and the square root of 4 is 2. So this becomes plus or minus, and all of these things are multiplied to each other. So that's I times 2. So that will be 2I root 5. So x could be plus or minus 2I root 5. Or some people will write it this way, 2 root 5I. Some people will put everything in front of a radical. Some people will put everything as a big coefficient of I. I say they're both good in my class. I don't have a preference either way. Okay, so there's the sort of scenario when you might encounter I for the first time, taking the square root of a negative number to help you solve an equation. So no real solution to that equation, but an imaginary one. Okay, so now some of these things you're going to run into when you're simplifying expressions that have I in them, or when you see this, for example, and you're asked to multiply these two square roots, you might notice that there's a square root of a negative number for each one. So you might be asking yourself, should I multiply these first, these two radicals together, and I'll get square root of negative 12 times negative 5 is positive 60. Should I do that and then reduce from there? And that would be, 2 root 15. Or should I deal with the negative first and pull out the I? And you might think it doesn't matter, but it actually does. It's kind of an order of operations thing. As soon as you see those negatives, they need to be addressed and factored out. So I'm going to take out square root of negative 1, and that's I. And then you'll have I root 12 times, and I'm going to take out I from this second one as well. And that's just taking out square root of negative 1. So I'm going right to calling that. And now you have your option of multiplying first, or you could reduce that root 12 a little further if you like. but at least you've taken out the i's. That's what the important part is. So I don't know, let's just simplify this root 12 portion first. Root 12 is root 4 times root 3. Square root of 4 is 2. So that will become 2I root 3 times I root 5. And now when I multiply these, although I represents the square root of -1, it acts very much like a variable. You know, you treat it that way as you're multiplying. So this is 2I root 3 times I root 5. So 2 times 1, that's the coefficient of I in that second portion, is 2. I times I is I squared. And root 3 times root 5 is root 15. Now, here's the one thing that you need to remember here, that if the square root of -1 is equal to I, then that means I squared is always equal to what happens if you square a square root, that it kind of cancels out the square root, takes it away. So I squared is equal to -1. And so anytime you run into simplifying expressions with I, you're never going to leave it, generally, you're never going to leave it to an exponent bigger than 1, because there's always a way to reduce it. So for example, I squared is really equal to -1. So this is 2 times -1, or -2 root 15. So whenever you get I squared, you basically just remove it and make the term negative. So -2 root 15. And so you see we actually got a different answer than if we had just multiplied first, which would have sort of, gotten rid of the negatives as if they were never there. So do not do that. Deal with the i's first. Take out those negatives, call them I, and then go from there. Okay, there's one. And now how about part B, where there's already a bunch of i's? And this is really just a fancy Algebra 1 problem, except there's some i's are in it, where we're going to distribute and simplify. So 3i times 2 is 6i. 3i times -8i is going to give us -24i squared. And there's that I squared again, which we're going to change in a moment, or some of you will change right on the spot as you get it. In the second quantity, don't make a careless mistake here. We're distributing -5 to each thing here, so we're going to get -20, and -5 times -I is +5i. So I'm going to do a couple things here. I'm going to combine my like terms, but I'm also going to change this -24i squared. Remember, we just said I squared is -1. So if I were, trying to take my time, not do too much at once, that really is going to become +24, right? Because that's -24 times -1. So just +24. And now we're here, and now it's just combining like terms. 6i and 5i will give you 11i, and 24 minus 20 is +4. And we are done there technically, but we're going to talk about standard form of this is what's called a complex number, by the way, because it's not just a pure imaginary number. There's also a real component to it. So when you have a real number mixed with an imaginary number, that's what's called a complex number. And the directions didn't say you had to express it in standard form, but standard form means to always put the real part first, or what we call a plus bi. So I'm going to do that just for maybe good habits, even though the directions didn't specify that. So this is standard form of that complex number, or as it's often going to be sort of written, a plus bi, real plus imaginary. Okay, and lastly here, again, this is just like a variation on an Algebra 1 problem. 4 minus 3i squared, squaring that quantity, big thing. Don't make a careless mistake and think you can just square the two terms, right? That means you are squaring that binomial, so it's 4 minus 3i times another 4 minus 3i. And if you can do that in your head, go for it, but don't forget that means you're doing a FOIL, so you're distributing, right? Everything from the first quantity to everything in the second quantity. So, 4 times 4 is going to give you 16. The outers, 4 times -3i is -12i. The inners, you're going to get another -12i. And negative 3i times negative 3i, again, watch that. You're going to get positive 9, but I times I is going to give you I squared. So immediately, what is that really going to become? 9 times negative 1, that's going to become negative 9 right there. And if you can start to simplify these things, that's, that's great. If not, you need to take a step and rewrite things, go for it. But 16 minus that 9 on the end is 7, and minus 12 is minus 24i. And that's in standard form because it's real and then imaginary second. Okay, so there's another kind of one, and here's the last problem that we're looking at in this video, and this is when you're dividing a complex number by another complex number. 2 minus 5i times 7 minus 3i. As you may recall, you are generally not supposed to leave radicals in a denominator in a final answer, and I is the square root of negative 1. So we generally don't leave I in the denominator. So we're going to rationalize the denominator, just like we did with any other radical, root 2 minus root 3, 7 minus root 5, whatever, by multiplying by something to rationalize it. Now when you have two terms, 7 minus 3i, we're going to multiply by the conjugate, which conjugates are always a plus bi and a minus bi. Those are conjugates. A little vocabulary there. Your teacher will be very impressed if you know that term. And if you don't remember that, you'll see why that works to rationalize or get rid of the I in the denominator. But in a fraction, if you multiply the denominator, you got to multiply the top, because that way you're just multiplying really by a fancy version of 1, because this divided by this is just 1. So you're not changing the value, so here we go. Now, I'll do the denominator first, because that's what we're really concerned with here. And here's what's good about conjugates, is that they are a plus bi and a minus bi. Those are like a difference of two squares. So you really don't have to FOIL and do the outers and inners. If you do, let's see what happens. 7 times 7 is 49 for sure. When you do the outers, 7 times positive 3i is plus 21i. And when you do the inners, you get minus 21i. Those are going to cancel each other right out. So why did we bother to do them? Because that's always going to happen with a difference of two squares, with a minus bi and a plus bi. But anyway, let's not forget the last term, though. We got to do the first and the last, and that's negative 3i times positive 3i. That's negative 9i squared. Watch those signs. Watch the I squared. That's where you'll make a lot of careless mistakes. And now when you simplify this, you see what you're really doing here? The 21i minus 21, those two just cancel each other out, those like terms. And 49 minus 9i squared really becomes plus 9. So 49 plus 9 is 58. And that's that. See, the i's are gone. And that was the beautiful thing. Now the numerators here, those are not conjugates, so we definitely have to FOIL those out. So 2 times 7 is 14. Outers plus 6i. Inners minus 35i. And lasts, negative 5i times positive 3i is negative 15i squared, right? And negative 15i squared is going to become plus 15, right? Again, that I squared, take it out, change the sign, because I squared is negative 1. Now combine your like terms. 14 plus that 15 that's now on the end is 29. The middle term, 6i minus 35i, is negative 29i. And notice the directions here actually say standard form. And standard form, again, means a plus bi. That means breaking up this fraction into two separate fractions. A real fraction, 29 divided by 58, minus 29 divided by 58, with the I attached, and treating that as a, one big coefficient, 29/58. So yes, you're dividing both of these by 58. So just divide them each individually by 58, and that's standard form. And now we have to also reduce, of course, and it just happenstance that these happen to be the same fraction. With 29 out of 58, that actually reduces to 1/2 minus 1/2 I. And there we go. 1/2 minus 1/2 I There's your final answer in standard form. So you got a good taste of some complex numbers, and hopefully it was a good review of some of those things. If you like it, hit like, and if you have any questions, let me know in the comments. But otherwise, keep working hard and have fun, kids.